I think we're recording now. Okay, great. So we're going to start off by looking at these tutorials real quick. We had a question on one of them. So to get to the tutorials, again, you go to Help, Max Documentation. It'll bring up this documentation browser. And if it's in some other section that's not this, go up into the upper left-hand corner and click on this little house. This little house here, that will take you home to this screen. Then down in the lower left-hand corner, there's the content, table of contents. And we want tutorials under Max, which is right here. So then the assignment for today was to do Max tutorials 1 through 8. So we had a question about tutorial 6, simple math in Max. So with these tutorials, I think it's really important to not only look at the patch, but also read this text, because it will tell you how to use the patch to demonstrate whatever it is that they're trying to teach you. So I believe the question was, can you explain this TBF and TBI right here? So T is short for trigger. You could just as well type out trigger BF, right? And if, as we remember from last week, B and F are symbols that mean float and bang, and I would be int. Yes?
Can you please make the window a little bigger?
Yes, let me zoom in. Yeah. Maybe I zoomed in too far. How's that?
Yeah, good.
Great. Okay. So I could just as easily type trigger BF, right? So if you were, I'm going to leave the tutorial stuff alone, but I'll build the same thing over here. If I was sending a value into this, like 15, what's going to come out the other end? Well, if you hover over the outlet, it will tell you this one here is output order 1, and it's a float. Now, we didn't get a chance to go over order of operations last week like I had meant to, and we're going to go over that first here in a minute. So we'll be going over this again. But I'll just say it really quickly. Max works from right to left and from bottom to top. Basically the opposite way that you'd expect it to work, right? Because when we read, we're reading from left to right and top to bottom, but it's the opposite. So just remember, opposite. And it doesn't matter about patch codes. It's the location of the object that determines the right to left, up and down. It's geographic location on this canvas, right? So because things go right to left, the outlets also go right to left. So the furthest right outlet goes out first, and it tells you that there. It says trigger output order 1 float, right? Because we specified that by putting an F. So if I connected that to this box here, and then on the right outlet of the right inlet, of the message there, and the other outlet of this trigger to the right inlet of another message box, lock the patcher, and click the 15, you'll see that value 15, which is actually an int, right, because I didn't put a period after it, is getting converted to a float because we said to trigger a float. That's why there's a period after it. And the B, it totally ignores the value entirely and just sends a bang. So you can use this when you want certain values to trigger something else without having to send their value down the line, because maybe that value is going to throw off something and you just want to bang. You can use a trigger to convert a message into just a bang, or into an int, or into whatever you want. You can also put, by the way, trigger something. And now, I've only put one thing here, so it doesn't have two outlets anymore. It only has one outlet. But you can see I can send a 15 in it, and it's going to send out something. It doesn't care, because it's just telling me whatever input you get that's going to trigger this, which something. And because something isn't recognized as an int, a float, or a bang, it's automatically a symbol, and whatever symbol, whatever you type, that's the symbol that's going to be sent out the other side. Is that clear? Was there any other part of that that was confusing, like the math or something?
Can you talk about the Fahrenheit to Celsius patch we were supposed to do? I screwed up mine somehow when I tried to do that exercise.
Can you remind me, what were they asking you to do?
Let me look it up.
I mean, there's a little patch here that I guess that's to check your answer.
Yeah.
Oh, they were telling you let me see. Math objects, conversions, the result. Left hand out, 14. What? What exactly? What were they telling you to do in the patch?
They were saying, let's see, unlock the patch and begin by using a number box for the Fahrenheit input. Connect this to a minus object with an argument of 32 as the default right-hand operand. It's in the cascading math object session in the tutorial.
Okay. So,
can you read it out loud?
yeah, I guess I just didn't get a chance to go through this tutorial. So yeah, that's why I don't know it. All right, so yeah, just talk me through the steps, one thing at a time, and I'll do it in front of you.
Cool. So it says, unlock the patch, okay.
Yeah.
Begin by using a number box for the Fahrenheit input.
Okay.
Connect the number box to a minus object with the argument of 32.
Okay.
Connect the output of the minus object to a multiplication object, so the asterisk object.
Yep.
With a 5 as an argument.
Okay.
And connect it to a division object with 9.
Whoops.
Slash.
There we go.
Yeah. Did you put 5 as an argument for? Yeah, you did. Sorry.
And then just the result of that.
Dot as because you want a decimal point.
Right.
Sorry. Finally, connect the output of the division object to a float number box.
So that's the wrong kind.
Yes.
Okay.
And that's what I thought we did.
All right. So if you put this in here, it says that 66 degrees is 18.89 degrees or Celsius. So what's happening on your end?
I think I just entered in the wrong object for the final box, actually. So let me try that again really quick, because that's the only difference I'm seeing.
Yeah. So what she was saying, basically the important thing to get from that was what the arguments were and what each object is. So this is a minus object. The argument is 32, right? What does that mean? That means we're subtracting 32. This argument is 5. That means we're multiplying by 5, and we're dividing by 9, period, which is float.
And to enter a float number box, you literally type in float, right?
You can, well, if you spawned a new object without like that,
Yeah.
you would have to type the word flonum.
Flonum. Oh, that's what I'm.
But what's a lot easier is just hitting the F, which is the shortcut.
Gotcha.
It's just hit an F instead of N.
That's exactly what happened. I entered the wrong object.
Yeah.
Okay.
So I guess, yeah, if you had an int, if you had a regular number box, right,
Mm-hmm.
it's going to truncate all of those, all of the whatever is less than 1. It's just going to cut off the decimal places.
Cool. Thanks.
Yeah. All right. Any other questions about the tutorials? All right, let's move on. All right. We are going to start off today with Tough. Let me try that again. Wait, let me reset. There we go. Ah! All right, one more time. Here we go. There we go. So apparently there's a bug in it because it starts with tough the first time you do it. All right. First thing, I don't know why I forgot this because it's really important. Comments. You should be commenting all your code. I think I told you this like at the end of the class last week when it helped you not a bit. Yeah, so comment, the shortcut is C. That brings up this comment box type stuff. Comments can't be used to send anything out. You can't use a comment to send a message or anything. They're only used for commenting or displaying text. So you should be taking notes about what the things do that we are patching along. As I'm explaining it, I probably won't have time to comment the code much, and so you should be making your own comments and explaining things. So there's a couple different type of comments. There's just the regular one. You can also go into inspector for a comment. And inspector, you can do this for any object. You can go into inspector, and that shows you what the attributes for that object are. Do a command I. So type a comment and then put some text in it, and then do a command I, and then go over here and click on bubble. And that turns it into a bubble. And you can also you can change where the arrow on the bubble is. Like by default it goes to the left, but you can make it be the top or the bottom or the right. And you can even make that little pointer go to different places. You could even if you wanted to, you could even automate it. Right? So yeah, so all I'm doing here is I have a counter here that's counting up, and then I'm multiplying that value by 0.2 to get, the different, I'm taking 50 steps and making that into a value between 0 and 1, and a float value between 0 and 1. And then the argument is bubble point. And so that gets sent to this bubble, and now it's making it move the bubble point. Basically what I wanted you to know here is use comments and use the inspector to change things for your comments. Order of operations. This is a new thing we didn't go over last week. This is really important, and it can really confuse the hell out of you sometimes why your patch isn't working right. And it's usually, you check everything, everything's hooked up right. There's no reason why it shouldn't come up with the right value, and for some reason it's doing the wrong value. It's usually because you have the order of operations wrong. So like I said before, max works from right to left and from bottom to top. That's wrong. Bottom to top. There we go. So backwards that I even said it wrong. All right, so what does that mean? Well, so you can look at this first example right here. Let me zoom in a little bit for you guys. This first example here, this yellow bang is going to trigger all of these bangs, you would think at once, but it's actually not at once. So take a look. Do a command M to get into, oh wait, you guys don't even have this stuff. Let's build this really quick. Let's build this. So go ahead and just copy this section right here. So start by making a bang. Whoops, I hit N, I guess. B is the shortcut for bang. Then we want 1, 2, 3, 4, 5 more bangs. 1, 2, 3, 4, 5. You just hit B. So pass this bang into all of the other bangs. Okay, and now we want these all to actually be on the same level, and I'm sure when you drag them, they're probably not. And there's a shortcut to arrange that way, and it's command Y. So do a command Y. So that should line up all of your all your buttons. It will also command Y. It will also arrange vertically. It just guesses what you want, horizontal or vertical, based on the orientation of things. So like it knows that when I'm selecting these two that are mostly vertical, that when I arrange, I want them to be arranged vertically. But what it does do is whichever, and this is kind of confusing because it's backwards from the order of operation. But when you're doing arranging, it's going to arrange based on the furthest up and the furthest left thing, which is opposite of the order of operations. So yeah, if I moved this guy up here, right, and I select all of these and arrange, they all go up to his level because he's the furthest left. All right, so now these are all on the same level, right? Then we need these words. So 5 messages. 2, 3, whoops, 3, 4, 5. And you can type that, or you can type just A, B, C, D, and E if you want. A, B, C. Whoops, get out of the way. D, and E. Okay, again, line all these up. So now these don't have any vertical precedence. All right, and make sure you're connecting to the left inlet of this, not the right inlet. And let's see. I guess I should probably line these up vertically with their bang buttons. There we go. You can also move things around with your mouse, and it will give you these little guidelines that tell you when things are lined up. Little orange guidelines. Okay, and then we want a print object. And then put some kind of argument to give it an identifier. So we'll call this print order. And now pass all of these into the print. The outlet of all of the messages into the print object. And now, what do you think is going to happen? Well, I'm sure some of you probably already pushed it, so you know. If you look what happens there, order, we lined these up backwards, E, D, C, B, A, going left to right, but it came out A, B, C, D, E, right? I should probably make that even more clear by moving these around. A, B, C, D, and E. Also, if you're doing a whole bunch of printing to test things, sometimes your several different print objects can get confusing. You can clear everything in the Max console over here by clicking clear all. So now you can see it's going from right to left. E, D, C, B, A. Oh, by the way, if you're, to click something, I have to lock the patcher, but you can override that function. If you don't want to lock your patcher and you just want to quickly test something, you can just hold down the command key and then go ahead and click it, and it'll let you click things, even if your patcher isn't locked. So that makes it quicker in testing. So this here that I just built is the same as this thing over here, right? See, these thee, love, I, do, how ends up being how do I love thee, question mark. That was from the tutorials. You probably recognize it if you did them. So this is the same. So what's going to happen when I click A right here? What values will be printed?
60, 50, 40.
Great, but what else is it going to print? It's going to print one other thing before it prints 60, 50, 40.
The letter A.
That's right, because that's our little identifier. Before it was, this said many, right? Many, 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 many. Now it's going to say A 60, 50, 40. A 60, A 50, A 40. Great. What's B going to put? Let's try it out. Nope, it's B 70, 80, 90. Remember, bottom to top. So here's the real confusing one. What is C going to put out?
Starts with C.
Yeah, don't care. Just don't worry about the print tag. Just give me the what letters.
F C E B D A. Is it F E B?
It's FCEBDA. Right to left, bottom to top. So the first thing right to left is F, because it's the furthest right and the furthest down. Then the next furthest right is C. Then the next furthest right and the furthest down is E, and then followed by B, then D, then A. So that's the order it goes. So you guys, let's build those really quick. So just have a bang, and then a couple messages, 3 messages, 40, 50, 60. Line these all up. Print A, send them in. Great. That's one of them. Then the next one, a bang. 3 messages vertically. Line those up. Print B. You can grab another object and duplicate it. Sometimes that's quicker than making it from scratch and just changing the title or changing the arguments. A bang, and then 6 messages. Message, 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 message. Those line up. These line up. This, and then just make sure that they're also lined up vertically. Cool, that should work now. Oops, I'm missing one. Oh, I didn't connect those, no wonder. If you don't connect it, it's not going to print. There we go. Okay, there's that. I got it better up here, so I'm just going to delete that. All right, so if you're having trouble, you can always use triggers to set an explicit order, right? So this, if I did it the same way before, and I just passed this bang directly into this 40, 50, and 60, what's it going to put out? It's going to put out 60, 50, 40, right? Because it's going right to left. But by using this object called bang bang, which is basically just triggering multiple numbers of bangs, it's exactly the same as trigger bang bang bang, right? Bang bang 3, bang bang is an object. Bang bang. Yeah, I think Bam Bam came up with this. Output a bang from many outlets. So you put its default argument is 2. You could put up, you could put 10 and have 10 different bangs, and these you can know that that the first bang is always going to come out here, and the last bang is always going to come out here. So even if your objects are all over the place, you can make sure that things are happening in the order that you want. So if I wanted so in this case with the 40, 50, and 60, I wanted the order to be, I wanted it to go in that order, but the geographic location of the objects are wrong. But this is a way by moving these patch cords around. So the one furthest to the right is going to go to this 40. And if you hover over it, it'll tell you that's the first bang. That's the second bang. Bang output after right outlet. And the last bang, right? So last bang is going to go to 60. Middle bang is going to go to 50. And the last bang is going to go to 60. So 40, 50, 60. And this is, again, the TBBB is the same thing as bang bang 3. ABC now. And you can also do, this is what I showed you before we started today when we were talking about the tutorial, that you can use a trigger to convert values and also just to trigger things. So if I click the 90, what's that going to print on the other side? So the first thing, all you have to do is read this backwards, right? So the first thing furthest right is going to be an int. So that should be what's going to come out if I put in 90 on the input. 90. And then the second thing that's come out is going to be a float. So what's that going to be? 90 with a period. And the last thing is going to be a bang. So 90, whoops, what did I just do? There we go. 90, 90.0, and bang. Cool. Let's talk about recursion. So you can put the computer into a feedback loop where, say, this bang is looping into other bangs. So this bang, when I hit 1, that's going to go down to 2, then it's going to go out of 2 into 3, out of 3 into 4, and then out of 4 back into 1. It's just going to be going in a circle. But a computer does things so fast that just stacks up faster than it can deal with, and it uses up all of its memory. And so in order to keep that from happening and crashing your program, Max has a detection thing that will detect a recursion feedback loop and lock everything down. So if I click this, boom, Stack Overflow. It says Stack Overflow outlets. Let me zoom in. No, I can't zoom in that message, unfortunately. Yeah, I can. There we go. Outlets are disabled until this message is cleared. So if that happens, can it tell you? Yes. So if that happens, your natural inclination is just to clear it, but that's not going to tell you what is broken, right? So if you double click on the message, it will highlight the object, the offending object. Look down there by the 1. See that green dot? Right? So do that before you clear it. Now that you clear it, now you can run things again. But if it's in lockdown, I can't do anything. Like all these, nothing's printing. Everything's locked down until I clear that. That's an improvement over like Mac's before they came out with that, I believe in Max 5. But before that, if you had a recursion loop in your patch, you're just going to crash. And you better have saved because everything you did is gone. That's another improvement in Max 7 is that now Max 7 has a crash recovery system. So you should definitely be saving quite often. I mean, the stuff we're doing is in these early classes is unlikely to crash, but because these kind of recursions are usually handled by the program, no problem. But once you get into a really complex patch or you're doing stuff with live video or live input, stuff like that, your chances of crashing go up, and you should be saving so that you don't lose anything. Because, yeah, the crash recovery will recover most of your work, but it only takes a snapshot every couple minutes or something. So you may have lost up to 15 minutes of work, which can be really can be more than 15 minutes to resurrect because you have to remember what the hell you were doing. All right, so the last thing is keep your patches clean. So I guess, the one thing this is really important to do so that you can debug your patch and know what's going wrong. If I have objects all over the place, then it makes it really tough for me to trace out, where is this line going, which object is that going into. So one thing you can do is when you have sections of code that work really well on their own, and like this whole section of code has one input and one output, but there's a whole bunch of stuff in between, you can encapsulate all of that into a subpatcher. So say I have all this, take this print C stuff here, right? Everything in the middle, all this has one input, this bang, and one output, this print. I could, if I wanted to, I could hide everything in the middle so that I don't see it by selecting it and then doing a Shift Command E to encapsulate, and that creates a subpatcher that you'll want to give a name. So order op, right? When you give it a name, make sure you don't have any spaces in the name, because the spaces would be considered an argument for that patcher. Just like if I have, print A, that A is an argument, it would think that I was using an argument in my patch. We'll go into our arguments and subpatchers way later in the term. That's something that's more advanced. But for now, just suffice it to say you don't want any spaces in your subpatches.
Can you put it between quotes and it works?
Yeah, I guess. I mean, yeah, sure. If you wanted it to have a space, I guess you could do it. Well, let's find out. I think you can. Yeah, that works. Because it's treating that as a symbol and not an argument by doing that. All right, so once you encapsulate something, if you want to go back in and make changes to it or edit it, you can double click it, and then it automatically replaces the input and output with these little symbols, which are inlets and outlets. This one only has one, but you could have more than one. So you grab this and duplicate it. Now you have two. And you can see over here in the subpatcher, now there's two inlets. The second inlet doesn't do anything right now, but it's there. You can have more than one outlet. So if I say I just had this one pass straight through. Bang. Add a bang over here, send that in, bang down here. Just goes straight through. The other one still does what it did before. So that's a way of really, if you have a really messy patch, clean it up by isolating sections of code and then putting it in a subpatcher. I still want you in your subpatcher to make things as neat as possible. Don't just use the subpatcher to hide a bunch of messy code, because that's not solving your problem of debugging the program if it doesn't work right. So one benefit of doing that is now also this section of code is really easy for me to duplicate. Now I have more than one, and it's the same thing inside. So if you encapsulate, if you're going to be doing the same thing a bunch of times, you can encapsulate that function and then have that subpatch be in different places in your patch, and then you'll know that those are the same function, and it just makes everything cleaner. One thing to know, though, to be careful of, though, is if you do that, you copy this over, and then you make a change in this patch, like instead of a C, now this is a T. It doesn't change this patch. This one's still a C, even though they have the same name. So that can be really confusing. So if you're going to change it, I would change the name to something else. There is a way to make everything conform. There's a way to use a patcher that's external to the program, but that's an advanced thing that we'll be covering later in the term. But for now, yeah, if you do have multiple subpatches, either keep them all the same, or give them different names. And if you make a change and you want that change to be in every single one, you could just make the change in the one that you wanted, and then replace the other ones with that. So now this is the one that has the T in it, right? ABT, whoops, T. And I wanted this one to have the T also. I could cut this or copy this. And then there's a special paste called paste replace. If you go into edit, paste replace, which is, what is that? Shift Command V, or is that Option Command V? Option Command V? Option Command V. Now it has the same name, so it's kind of confusing that it did it. It might be better to know that you've done it by giving it a different name first. Option Command V. Now I've replaced without having to make all those new connections, all those connections all over again. It's just replaced that with the new one. Now the T's there. Questions?
I don't know if you would ever want to do this, but could you put like a subpatch inside of a subpatch?
Yes. Yeah, you could have as many levels of subpatchery as you want. So you could encapsulate that, and then inside there encapsulate it again if you wanted to. Yes. And sometimes if your subpatch is really complicated, you'll want to do that. Okay. Let's see. So that's encapsulation. Let me talk about resizing stuff. This is handy, especially when making comments. So if you're typing God, my keyboard's slow. See how long this is, like much longer than my text? And say I just I'm just want a B or an A, an A. I have this huge box for just an A, and I could, if I wanted to, I could hover over here and drag that back, set it to where I want. There's a shortcut for that, and it's Command J, and it just automatically resizes it for you. Also works on objects. So print A. Oh, that's new. I think that's new in Mac 7. It didn't used to resize the box automatically for you. It used to have to do the same thing of a Command J to get the box to change. But sometimes, so I guess the box will automatically resize itself for you now. That's cool. But sometimes you want it to be wider than it needs to be, just because it makes the patch cords line up in a easier to see manner. So like say I had, what did we do? Last week we did packs and unpacks, I think, right? Yeah. So say I had a pack and an unpack. So I have a couple ints. Come on. Oh, I keep hitting U instead of I. No wonder. Do I have any more room? Come on. I hate this mouse sometimes. One thing I don't like is I feel like they don't give you enough margin. Sometimes I'll grab a comment and just throw it way over here so that it gives me a margin. Or up high or down low. Okay, so we have 3 ints. Let's have a pack. Darn it, I'm hitting the wrong buttons. Pack 0, 0, 0. And then say an unpack 0, 0, 0. Or say it was like this. Say we are unpacking a list first. Let's put the unpack up here. Put a list up, a message up here with a list of 1 space 2 space 3. So that's a list of 1, 2, and 3. And I'm sending that into each of these number boxes. So see how this first patch cord is vertical, and then this one's kind of slanted, and this one's slanted even more. Sometimes, to make things clear, I'll resize this unpack to be the same size as the spatialization that I have on the on those. And now that makes it just visually, that makes it easier to see what's happening. I don't even need that pack anymore. But yeah, so that's one reason to resize something bigger, is to make these patch cords be vertical and really easy to follow. Another thing you can do is use sends and receives to eliminate patch cords. This is something I do especially if I'm sending data from the bottom of the screen back up to the top of the screen. So say this message down here, this 1, we wanted to send back up to, I don't know, the one of these bangs up here. I could send this patch cord all the way up here, right? But now I have this big ugly patch cord in the middle of my patch, and it's in the way of everything. I can try to arrange it or make the patch cord look prettier by doing a command Y. And that arranges it to be either, makes it just horizontal and vertical, and you can move this around. And sometimes that's good enough if you got enough space. But usually if you have a big patch with a bunch of objects, that's just a really hard line to follow when there's so much on the screen. There's not much on this screen, but when you get a complicated patch, having a really long patch cord is really hard to follow where it's going. So what I do instead is do a send object. So you can go new object and say send. Not sent, send. And then you have to give it an argument. Send, give it a name. Send to top. Now I can receive to top up here. Receive to top. Needs to be spelled exactly the same way as the send, or else it won't work. So same capitals or no caps. Now, if I put this up here, I can hit the bang down here, and it will actually go all the way up to the top. Did you see that bang light up? So now that's a way of sending things without having physically connected patch cords. And sends will work for any kind of data. They'll work for messages, they'll work for numbers, they'll work for video data, they'll work for audio data. So they're really great to use. They'll also work outside of the program. So if you have more than one max patch open, like I could have a new patcher and I could, let me just copy this to save some time. Receive to top. And hit this. Didn't it go? Well, that should have worked. Oh, I know why, because I put it on the wrong side of my message, so it's not doing anything. I have to put it in the right inlet. There we go. See? It sent the value from here, this 1 that we were sending, sent it out of the program into this other patcher. And that can be really helpful too, especially when we get into what's called model view controller paradigm, which is where you're essentially you're taking the essential functions of your patch, whatever the engine that's creating the video and the interface that's controlling it, and then there's some middleware that's making decisions about things. You can actually have those as 3 separate programs all communicating to each other via sends and receives, and it makes for a really modular patch that's easy to expand upon. And it has other benefits that I'll talk about when we get into model view controller. I don't want to bore you guys to death yet. Yeah, it's pretty stiff, but it's very useful once you get your head around model view controller. But that's for a later day. Other things, so we talked about aligning patch cords by doing Command Y. Select patch cords by option dragging. So if you have a messy patch and you have patch cords that are really hard to follow, you can option drag the patch cord from, like, say you had a whole bunch of patch cords coming from one object, like this guy here. I can option drag and it will select patch cords. It will also select objects, but it will select patch cords. So you can just drag over the patch cords here and then it will highlight where they're going. So that's a good way of figuring out where things are going. And then you can then use your Command Y to clean things up if you want or need to. Another thing to do is called routing the patch cords. So you can do routing the patch cords uses a little algorithm to try to put little bends in the patch cords to move around objects that might be in the way. So if I had, let's see, I'll just do something for you guys really quick. Bang, make a bang, a couple message boxes, a couple ints. I'm hitting the I key. And let's call 1, 5, 10. So say let's see. Say I wanted these, the output from these int number boxes to Y, to go over here. Do pack 000 and put it up here. It's a stupid thing to do, but it's just to demonstrate this. So for whatever reason, geographically, I didn't have space or some other reason, I had to put this object up here, and all these cords are, going through the middle of everything else. Add another message so we can see this. You can highlight these cords which you can select by clicking on, and then if you want to select more than one, you can hold down Shift and click on the other ones. And now do a, Shift Command Y, and it does that thing. It does this computer algorithm that tries to figure out what the best way to have these chords move and not be in anything else's way. That sometimes is helpful, other times it just makes it more of a confusing mess. So I try to I often will avoid that. But really, it just would make better sense if this wasn't up here and you were able to put it below this. The other thing it does is that once you've routed it, it locks those, and at least initially, it locks in all those bends. And so now I move this thing around, even though I moved it down here, now my chords go all the way up here and then back down again, which is even more confusing. And so now I'd have to reselect all of these chords, and by doing an option drag, and either do another Shift Command Y, and now things worked better, or I could do a Command Y, which Command Y would just give you this little S bend and wouldn't care whether it was running through another object or not. The other thing I do when I'm lining up patch chords is I try to make sure that things that are on the same level are all either coming from the same place or all going to the same place. So if this, say this here was also going to a message box over here, and I had it connected with these, now it's really confusing where this is going, where the data coming out of this is going, because it's these two are lined up with each other, this one and this one, and it makes it hard to tell that this box is sending to this message. So what I do, if you have data paths that are going to two different places, I'll put them on different levels like that. Now it's easy to see that this one's going there and this one's going there. Make sense? All right, let's, any questions on this before we move into slot machine? All right, cool. So go ahead and save that if you guys have been following along. Save that, whatever you want. I call it class 2.1 because it's the second, 2.1. This is the second class meeting. This is the first patch that we looked at. This will be on the website as soon as there is one. All right, I'm going to save as. All right, so let's make a new patch from scratch. All right, so slot machine. First thing, if we're going to design a slot machine patch, it's helpful to understand how a slot machine works. Because basically we're going to be using a digital system to recreate the mechanical processes that are happening inside of a slot machine. So slot machines will work, I mean, nowadays they're actually completely digital and the wheels are just a lie. Like the computer picks 3 random numbers and then makes the wheels spin so that you think that the wheels are doing something. And the wheels will just land on the 3 numbers that they picked. But it used to be a mechanical system, and there used to be two different ways that it was accomplished. And this is one of them. So the way this works is you pull the handle down, that creates spring tension that sends a kicker that kicks those wheels. And those wheels, because of friction forces and stuff, they all kind of spin at different rates, slightly different rates. And then this particular slot machine is a little broken, so I have to kind of help it along. But what happens is there's this stopper plate that raises after you do this, and the stopper plate has these 3 different teeth that lock into the wheel and will stop it at a certain spot. undetermined because each wheel is going a slightly different velocity. So you have a long stopper that's going to stop this wheel first. Then you have a medium-sized stopper that's going to stop the middle wheel second, right? Longest one, that's going to click in first, followed by the middle one. The shortest one's going to stop the last wheel at the end. So long, medium, short. As this raises, stop, stop, stop. So you get a random value based on the random speeds of these wheels. They all stop at the same time, but some wheels are going faster than others, so you get, and it's unpredictable, so you get a random result. The other way to do it is to have all the wheels spinning the same velocity, and you randomly stop the wheel at a different time. And whenever you happen to stop it, as it's rolling around, that determines the random value. Now that is the method that I am going to show you guys today. You could do it either way in Max. There's really no reason why you couldn't do a random velocity. But it's actually a little bit simpler to do the random time because you don't have an individual, you can have one clock that's controlling all of the wheels instead of having an individual timer for each wheel that's running at different speeds, right? This way it makes it a little bit more simpler. It's simpler in a digital programming sense. It also is simpler for the processor to handle because it's not keeping track of multiple timers. Because a timer is a somewhat, not really, but a little bit costly performance activity for a computer to do. It does use some of the resources in order to keep track of that time. So having, it would probably take a lot of timers before you started noticing it. But if you had, like, say, 50 or 100 different metros in your patch, it's really going to start bogging things down. So if you can minimize the number of timers and delays and other things that are keeping track of time, it's going to make your patch run faster. So that's another reason why we're going to do it that way. This method, of course, is the simpler mechanical method of doing it, and that's why this cheap bank did it that way. All right, so let me look at my notes. Okay, so let's talk first about the slot machine experience. What happens when you play a slot machine?
Losing money.
That's true. That's definitely part of the whole Vegas experience.
You have to insert money to play, don't you? Or token?
Sure. Yeah. Let's just break it down into the steps. So the first thing is you put in your dollar, your quarter, your penny. You pull the handle. Then what happens?
The wheels start spinning.
Runs through a bunch of numbers.
Yeah. So you put in. So the first thing is you put your money in. Second thing is you pull the handle or push the button. That starts the game. Things start spinning, start rolling, and then at some point, what happens?
They stop. They land.
They land.
One at a time.
One at a time. They land one at a time. Then once the last one lands, what happens?
Buzzers will flag.
The computer analyzes what the result is and either pays out or doesn't pay out. So that's essentially what happened, the experience, and that's going to be the steps that we're going to reproduce in our program. We need to first start the game, get things rolling, stop them at random times, and then analyze the results and give a payout. So, let me see. Let's see. So the first thing to do to get things rolling is we need to make that clock, because that clock is what's determining, is what's making those wheels actually spin. So, and everything is based on this timer in our system. So to make a clock, we use a metro. So do a metro. Now metro, the argument for metro is the interval, and that's how many milliseconds are in between bangs. So if I did metro 1, that would be 1 millisecond, and it would do 1,000 bangs a second, right? So we don't need that. We don't need it to be that quick, and it probably wouldn't actually be able to keep up. If you try to do 1,000 bangs a second, it's going to slow down and it's going to drop frames basically. Plus, we just don't need that kind of precision. So we're gonna do it Metro 50. And so how many times a second would Metro 50 be banging? It should be 20 times a second, right? Because 20 times 50 is 1,000. So 20 times a second. So Metro 50, we need a toggle to turn it on, to turn the Metro on. And you can go ahead and put a bang down here real quick and go ahead and turn that on. You can see it banging. It's banging so fast that it may look like a steady light because it's every 50 milliseconds. All right. Now we're going to send that into a counter that is going to create our clock. Counter. We want the counter to count up to some value and then start over again. I guess it doesn't matter what it is right now as long as the value is far enough into the future that all 3 wheels have stopped. So for now, let's do 12 seconds. So that would be counter 1200. And then, oops, not a bang. Then let's send that into an inch so we can see our count. And now you can see it's counting up to 1200. Okay. And then if we want to turn this value into something that's meaningful for time, we can use some math objects, right? Because we know that with a Metro 50, that 20 bangs is going to be a second. So all we have to do is take this number that's rolling up and divide it by 20 to see how many seconds have elapsed since we started counting. So divide by 20 and send that into a int. And now you can see that's doing it every second. 0, 1, 2, 3, 4. So that will roll over every minute, actually. That's because of every 50 milliseconds, we're counting up to 1200. So 1200 20ths of a second is a minute, I guess. Okay, so if we wanted tenths of a second, we could do another math object called the modulo, which is it's a percent symbol. And modulo or modulus, that returns whatever remainder there is. So you have to put an argument in. Again, we're going to put 20. So it's going to say, after dividing by 20, what is the remainder? So dividing by 20, that's going to give us the seconds. Doing the modulus of 20 is going to give us the remainder of that division, which it ends up being the tenths of a second, same as tenths of a second.
Can you zoom in, please?
I will definitely zoom in. Okay, so now we got a clock. All right, so we're going to use this clock to drive our wheels. So first we need to make the wheels, and the wheels are just going to be number boxes, but we need to make sure that the numbers roll over like a wheel would roll over, like the wheel of fortune, like the wheel on Price is Right. So we want another counter, and look at what it says for the arguments on counter. Let me go into the help file for counter. Option click. And it says no arguments counts upward from 0. And then, let's see, I think it's over here. You go up to if you want to know what all the different arguments are, you can go up to where it says arguments here, and it'll list the different arguments. In this case, it only has one argument, and the function depends on the number of arguments. There's a number of objects that operate that way. It's kind of annoying because you don't know exactly what the argument means without having to read down here. But what you can do is you just highlight that, and then it will give you a better description down here. And it says if there's only one argument, it sets the initial maximum count value for that counter. So if I said, if I wanted it to go between 0 and 9 and then go back to 0, I could put counter 9, because then it would go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's what we're going to do. If we wanted, there's other modes, like you can have a minimum number and a maximum number. That would be if you have 2 arguments. You could have it, instead of its minimum number being 0, you could have it be 1. So go ahead, if you've opened this help file, go ahead and just play around here. 2, 3, 4, and it rolls back to 1, 2, 3, 4. So the minimum there is 1. If I didn't have that argument, like you could go in here and edit this, take that argument out. Now it's going to be 0 is the minimum. 2, 3, 4, 0, 1, 2, 3, 4. Right? But with that 1, that makes it have a minimum of 1. 1, 2, 3, 4. You can have it go backwards. That one you need 3 arguments. The first argument, when you have 3 arguments, the first argument is the direction. 0 is forward, 1 is backwards, and 2 is palindrome. So loop backwards, 3, 4, 1, negative 1, 2, 3, 4. Palindrome, you can see here the first argument is 2 to put it into palindrome mode. Then its minimum is 1 and its maximum is 4. So it should go 1, 2, 3, 4, 3, 2, 1, 2, 3, 4, 3, 2, 1. Okay? That's enough on counter. So we need, for wheels, all we need is a counter 9. Not 98, just 9. Counter 9. And we need 3 of them for each of the wheels. Okay, and then we're going to want 3 more ints underneath those number boxes. I. Make sure you're on the right outlet of this counter. There are other outlets that do different things, like flag when it rolls over. Like this one here, this carry count, will tell you when the minimum is hit. It will send a bang when the minimum is hit, and this one will send a bang when the maximum is hit. Sometimes that's useful for other functions. In this case, we don't need that right now. Now, also, so you can open up the help file. You can open up inspector to get what arguments are. Another thing you can do is just hover over the inlet, and it will tell you kind of what that wants. And if you see, it says counter int, comma, bangs are counted. That means that if you send a bang there, it's going to start counting. Also, if you send a number, like an integer, actually, I guess it has to be an integer, not a float. That will trigger a bang as well. Let me make sure on that. Let me send a float and see what happens. So if I put 1 period, that's a float. Send that in there. Yeah, it doesn't. Oh, wait. No, I guess it does. That's kind of a lie. Any number will start the counter counting. But anyway, that's what we're going to do is we're going to actually use this number that's rolling over to drive each of these wheels. Even though it's not sending bangs, it's sending numbers. Those numbers are just disregarded by the counter. Send the number value from this over into the first inlet of each of these counters. That will get the wheels spinning. I'm going to move these down like that. Make my patch cleaner. It's always best to not send things, whatever is coming out of the outlet, it's better to have it be below that, just so that your patches make sense visually. Okay, so now we have the 3 wheels spinning, but we need a way to stop them. So there's a way to stop impulses getting through to objects by using another object called a gate. So we can put in between this number and these counters, we can put gates that will stop them from rolling. So go ahead and type gate. And by default, gate will just give you one outlet, and it's closed by default. And then you're going to want to toggle up here. So with the toggle off, the gate is closed. If I turn this toggle on, if I hover over this now, it says the gate is open, currently open. See that? Currently open. If I turn it off, it says currently closed. Okay, so go ahead and copy that. One for each wheel. And delete these patch cords. And this is kind of, this object's a little confusing. Sometimes I put things in the wrong place. So the first, this inlet up here, the left inlet, that's for the opening and closing, but the actual data comes in through the right inlet. So the number here, send that into the right inlet and then out of the outlet into the counter. Out of the outlet into the counter, out of the outlet into the counter, and then connect these up like that. I'm going to reline these up with my command Y. Actually, let's move them all down. Let's move these over to line up better with the counter. Just make things a little bit easier to track. It also makes it visually more aesthetic. If you want to be OCD about it, you can do you can do a command Y to get things perfectly lined up. And then also now these patch cords look kind of a mess. I can option drag and do a command Y. And now that's going. Of course, I'm breaking my own rule about everything that's going to different places being on different planes. So I want to move these around a little bit so I can see what's going on. How I'm doing what?
Just moving the patch cord.
Okay, so when you have a patch cord, if you haven't aligned it yet, you don't have any options. It just automatically does this kind of little S curve, this kind of lazy S curve. But if once you align it by doing a command Y or a route it by doing a shift command Y, then you can adjust the position of that with this. It can be annoying when things line up with each other and it keeps grabbing the wrong one that you don't want. Unfortunately, there's no easy solution to that. Okay, so now we have these gates and you can see these wheels are not spinning. We need to create a system to turn these gates on and off. So we need them to be on when we start our game and then just sequentially turn off, right? So we can use the clock to control that. I'm going to move this up, give myself some more room. So in order to do that, we need to add some logic. So we're going to add some logic over here. There we go, logic. We got it. No, I'm just giving you guys a label. All right, so logic, that's evaluation. It's math. It's the computer doing math and evaluating the numbers that are coming in. So what we could do is we know that certain numbers are going to equate to a certain time based on the metro's length, right? We know that 20 bangs a second. So if we wanted to have the first gate close after 5 seconds, the second gate close after 10 seconds, and the third gate close after 15 seconds, we could test for values that are greater than, from this clock, greater than 100, 200, and 300, because 100 would be 5 seconds, because that's 100 times 100 times 50 is 5,000, 5 seconds. 200 times 50 is 10,000, 10 seconds, so on. So and again, this isn't going to add any randomness into it, but this is the first step. I just want to get you guys past this, and then we'll add some randomness to it. So in order to do that testing, we need to use one of those math objects that does evaluations. And in this case, we want to do, is it less than or equal to 100? Now, when you do these logic objects, which are going to be, they're what's called Boolean operators. Greater than, less than, equal to, not, is. There's different ones, but in this case, we're going to in this class throughout the term, mainly what you're going to be using are greater than, less than, greater than or equal to, less than or equal to, or equal to, which ends up being actually equals instead of one equals. So in this case, we want less than or equal to 100. What is that going to do? Well, if the value is less than 100, this evaluation will send out a 1, meaning it's true. Because we're asking the question, we're asking the computer, is the value less than or equal to 100? If it's true, it sends out a 1. If it's false, it sends out a 0. We can use that 1 and 0 to open and close the gates for the counters. So if it's less than 100, this gate will be open. Once it gets past or equal to 100, the gate will be open. Once it gets to 101, that becomes a 0. It's false, and it closes the gate. So go ahead and less than or equal to 100 and connect that there. And you'll notice, well, it might take a second. Once that rolls over to 1200, in the meantime, I'm going to keep going. So go ahead and duplicate this and make this one 200. And duplicate that and make the last one 300. And connect that, and connect that. And it's almost going to roll over here in a second. Go ahead and connect that one and connect that one. So as soon as it rolls over, this gate should open. And actually, they all open, right? And then as soon as it gets to 100, this gate will close. 100, the gate closed. 250, 10, and that second one closed. And now the third one will close. Boom. And now we have our 3 numbers, which didn't, if I had started everything at the same time, these would actually always end up being the same number. But because I built these in different orders, there's a slight delay, but it's always going to be these numbers. If this clock rolls over again here in a minute, you'll see it's going to be 020 all over again, because we haven't added any randomness to it yet. So let's just watch that happen here in just a second. 7, 8, 9, and open. And it should end up being the exact same as before, 020. Close, no, 1. Maybe it's going to be 1 incremented. 131, yeah. So in this case, because of something's not exact, it's incrementing by 1 each time. But still, it's a predictable thing. If you had a slot machine like this, you wouldn't be able to stay in business very long. one thing, I guess what we need to do also, in order to get these numbers, we want these numbers to reset when we start the game, right? So we need to create a reset system. So the first thing we need to do is, let me see here. So yeah, first thing we need to do is make sure that all of the gates start off. No, I'm sorry, that all of the counters start on 0, right? Because we want all the wheels to start at the same place at the beginning of the game. And then we need to make sure that, where's the 1 going? Oh, yeah, and then we need to make sure that. So we need to reset all the counters. We need to stop this clock, reset all the counters, and then start the clock. Reset the clock, start the counters, start the clock. Okay, so in order to do that, we can use a trigger. Let's start with a bang. This is going to be our main reset / play the game button. Right, and now we're going to send that into a trigger, which you can also type just a T. I don't know why my computer is so slow when I type things in. It's being weird. But you can type trigger. You can also just type T. T, 1, 0, 0, 0. So again, it goes from right to left. So the first thing is going to come out as a 0. So whenever you're making your trigger object, whatever you want to happen first, just type that last. You got to type everything in backwards. And then you can just hover over that to verify that that's the thing that's coming out first. So this is a 0. We're going to send that 0 into the counter to reset it. Now, if you look at these counter inputs, different ones do different things. The first one, of course, is the enter, the bang that's making the counter move. The next one is setting that direction, can be a 0, 1, or 2 to make it go either forward, backwards, or palindrome. The next inlet is resets the counter to that number on the next clock. So it wouldn't immediately change it to 0, but it would, the next time it gets a bang, it would be 0. We want it to immediately change that to 0. So, and that's the next one over. Resets counter to number immediately. The last one is just changes the count maximum. We don't care about that. So send each one of these zeros into the second to last outlet on this inlet on the counters. So when this triggers, that will reset all of these counters to 0 immediately. Go ahead and hook that button to the trigger and let's test it out by hitting the trigger. Now it's 0, 0, 0. Okay. Then the next thing we want to do is I'm going to use this 1 to start this metro. Because technically it will probably, when we start the game, this will be off. And when we trigger this, that will turn that on and reset everything to 0, and then it starts. And now you'll see that they'll end up being the same value every single time because we haven't put any randomness in it. It's always going to be 1, 1, 1. What also, look what I did. I reset it and nothing's happening. Why? Well, it's because I'm already past 300. Now I have to wait for it to roll over. So what we should do is add to this triggering reset trigger. We need to add some kind of something to this counter to reset it to 0 also. So let's add a 4th 0. Let's put a 0 in between the 1 and the 0. Okay. Oh, that's annoying. We got to move all of these inputs over. Oh. You can either delete the patch cord or you can select the patch cord by clicking it and then grabbing this green thing, and then you can move it to somewhere else. And so now we have this fourth one's going to be a 0. We're going to send that to, oh, and now if I think about it, this might not be the best way to do it because this is still, Metro is still firing. We'll reset it to 0, and this Metro still might be firing before we send this 1 to turn it off. So we probably want to turn it off and then reset the counter to 0. So actually, instead of being this way, let's make this one be a 1 and the last one be a 0. And then let's change the order of these. Delete that patch cord and delete that patch cord. Make sure you're sending the 1 to that. And that is going to go to that. Oh wait, that's gonna turn it on, not turn it off. I know what. Okay. No, we do want it to turn off. We do want it to turn on because it should already be off when we hit this. But we don't, at this point, we don't have a system to turn off the Metro when the game is over, right? This third one stops and the clock keeps going. All we have to do is look at what is the last thing that's triggered. Well, the last thing that's triggered here is this this last gate is closed. And it's closed last because it's the highest number, right? So when this gate is closed, this will send a 0. We can use the same 0 to turn off the clock up here, right? So I could do a big, long, ugly patch cord like that, or I could route that patch cord, Shift Option or Shift Command Y. Still kind of ugly. Or I could do a send. Send. Let's call this. What do I want to call it? I want to call it. I didn't have a name for it before. Let's just call it timer stop. All one word, no spaces. Now the easiest way to make sure that you type the receive the same way is to just duplicate the send and then swap the S for an R. Oh, I didn't tell you that. I think before I actually typed out send. You can do it either way. You can be an S or you can type out the word send. Or type out the word receive or just put an R. I always put just S and R because it's quicker. And so now the timer stop will stop that when the game is reset. So now we should have a system that will stop these things, will reset everything to 0, start the clock, and then when the game is over, when the third one stops, it will stop the clock. So let's try it out. And the first one stops now, second one stops now, and third one stops now. And it stops the clock too. So that works. And if I do it again, and again, there's no randomness yet, so it's going to pay out every single time. That starts the clock again. Is everybody with me?
I think so.
Let me get rid of this ugly patch cord that I didn't need that we replaced with a send. There we go. Questions? I thought somebody had a question a second ago. Okay, cool. Well, let's save this and call this class 2.2. I think that's what we're on, right? What was the first thing I had you guys do? Class 2.1? Yeah. Okay, it's class 2.2. I'm putting the B's and stuff because I already have things. You guys don't need to put A's and B's or anything like that. Don't worry about that. Just put class 2.2. Okay, now, so we have that saved. Now save it as something else because we're going to make some changes. I want you guys to keep this version without any randomness, and now we're going to make a version that has randomness. So save as, and call this class 2.3. All right, and oh boy, we only have like 5 minutes. Okay, I think that's enough time to do some of the basic randomness. I wanted to go into give you guys a preview of win conditions, but I don't think we'll have time. All right, so randomness. So what do we do to create randomness? What right now is locking us into not having randomness?
The counter?
It's not the counter, actually. It's these. It's our logic. It's our logic because these are hard numbers. This 100, 200, 300. It's always going to stop at 100, always going to stop at 200, and always going to stop at 300. So it's always going to be the same values. So if we change what this value is to something random, then they'll stop at different times. So we can use the object called the random object. It's just a random object. And if you look at the random object, and you go into, I think you can do it in inspector. Does it tell you? No, I'm wrong. Inspector's not going to tell you anything. If you go into the help file for it, it will tell you what the arguments are. And basically, you want this range initial limit. And if you look down here, it says it sets the initial limit to the random object. This is the important thing. The output will always be between 0 and 1 less than the number that you put. Okay? So we want a random number that's 1 less than 100, so 99, and we want to add that to this 100 value, right? Because we're adding a random extra chunk of time to create uncertainty to this logic number that we're testing for, this 100 here. So random 100 will give us, we wouldn't want it to be random 101 because then there's the possibility that it ends up giving us 100. And when we add 100 to 100, it makes this one be 200, which is the same as the other one. And then you'll have two wheels stopping at the same time. And aesthetically, people don't like that. I guess there's, randomly that it's still a random system, but people want the first wheel to stop, then the second wheel to stop, and then the third wheel to stop. And if it doesn't work that way, they think the machine's broken, right? All right, so random, we don't want random 101, we just want random 100. We're going to add something to this value, so we need to add a add addition object and plus 100, right? Because we want it to be at least 100, because this could give us a 0 also, right? So if this random gave us a 0 and we added 100, then that would equal 100, and it would stop the same as this value. So random 100, the random number will go into this addition, 100 will be added to it, and then we'll populate the right inlet of this, which is set what this second number is, right? I could, at this point, I don't even need the argument here anymore because this is going to put that argument in there for me. So let's duplicate that, and this one's going to be also random 100, not random 200, because again, we're just adding up to 100 to the value. What you want to change to 200 is this addition object. And again, you don't need this argument. I'm going to pull it out just to make things clearer. You could leave it in and it wouldn't change anything. That whatever the argument, whatever that value is that you set, it will not change the appearance of this box. So if you put an initial value of 300 and then you changed it to 360, it's not through the random, it's not going to show up on this object. It's still going to say 300 even though it's really 360. So if you don't know if it's not going to be the same each time, you can just get rid of that so that way it's obvious that it's going to be something different each time. And so then we want to duplicate this and make that 200 into a 300, so that way we get at least 300. And I sent it into the wrong inlet, so that make sure you're sending it into the right inlet of the less than equal to object. Okay, and now we have our randoms, and we need 3 bangs to actually get our random numbers. Whoops. God, my computer's just lagging. I get rid of that stupid Windows boot camp. I think it's messing everything up. Yeah, Windows is good at that. All right, so we need to, so go ahead and click each one of these, just manually. Click one at a time. You won't see what the number is that came out. Actually, here, let's just for now add some messages down here so we can see what those numbers are. So put a message down here and take the 300 and take it to the right inlet, the right inlet, and the right inlet. And now click each one of these and you can see the first one's 184 now instead of 100, and this one's 251 instead of 200, and this one's 334 instead of 300. This way we've added randomness to when these things are going to stop. We just need a way to set those values before the wheels start spinning. And what did we do to set things up? Was this trigger up here. This is our kind of our game start reset trigger. So before we start the wheels spinning, we need to bang each one of these randoms. So on the right hand side of this list of triggers, we need to add 3 bangs. So B, B, B. That way they'll happen first. So this is the very first thing that happens now is this will bang. That'll bang, and then that'll bang. And so now those will all start, those will trigger the randoms, and then you'll have a randomly running slot machine. I'm going to make these a little bit bigger. You can go into the number boxes, and you can go into the inspector by doing Command I, and then you can change the font size, and it'll make the box bigger if you want like big numbers. And so now we have a working slot machine.
Cool.
And they'll stop at random times. And sometime, maybe. There we go. Wow, that must have picked a big number. There we go. So now you got a random slot machine. That's all the time we have for today. But what we're going to do, so I think I said that, did I say this was due next week? I think I said it's due next week, but I think I'm giving you an additional week anyway to get the win conditions. Let me see. Assignment due, yes, finish slot machine, including win conditions. So we didn't get a chance to do win conditions, but next week it'll be this slot machine that you did in class. And if you want to, so you'll turn that in to me just to make sure that you're doing it and that everything's working. And then we'll work on win conditions next week, and the following week we'll turn in the very final one with the win and the payout. Okay? And then we'll be moving on to actual Jitter video stuff.
Cool.
So this will be, I'll put this on the website as soon as I get it up, and it should be up by the end of the week.